All right, 10.3, operation radical expressions. Now, what we're looking here to do is simplify and combine the like terms. If you notice, all three square roots all have 2 in them. So basically, treat them as if they were like a variable, like x. So one way to think about this problem would be like 3x minus 5x plus 4x. Okay, so 3 minus 5 plus 4, that's going to be 2. Okay, so that would have been 2x. That's one way of how to think about this problem. Instead of it being x's, though, it's square roots. So you can actually remember, because a commutative properly add in any order. So if you want to, you can add 3 and 4 and get 7 square root 2. Don't change the square root, just change the number in the front. Minus 5 square root 2, and 7 minus 5 is 2 square root 2. At no point did I ever change the square root of 2. I only changed the number in the front. I added or I subtracted it. And that's the answer. So here with B, 6 plus 2 makes 8. 8 minus 9. Now I'm doing this slowly, doing each one at a time. 8 minus 9 is negative 1. So you can write negative 1 square root 11, or simply just write negative square root 11 would be a shorter answer. So as long as the square root which of 11s are the same, you simply add or subtract the numbers in the front. Remember, the 11's called the radicand. So if the radicands are the same, combine like terms. Now the last one here, we're going to put 15 square root 3 with the other square root 3. So 15 minus 11 is 4 square root 3. And then the square root of 5 parts will go together. So negative 14 plus 6 is negative 8 square root of 5. And you can't combine that together because 3 and 5 are 2 different radicands. And that's all you do. Okay? Now the next slide. Now these need to be simplified first before you can combine them together. You notice there's 54 and 24, 2 different numbers. But these can be simplified. 54 can be broken down, and so can 24. So 54 is 9 times 6. The square root of 9 is 3, and the 6 stays under the radical. All right? And 24 is 4 times 6. 4 is square rooted into a 2, and then 6 stays. Now in the front, there was a 2. In the front of this one, there was a 4. So I'm going to times it together. 3 times 4 is 12. 2 times 2 is 4. Now they both say square root of 6. So I'm going to combine the 12 with the 4, and my final answer is 16 square root of 6. So you're going to have to simplify them first before you can add, or in the case of B, subtract them. So if you'd like to do B and C, you should pause now and complete those 2 problems. Okay, so 12, 4 times 3. Now 48, some people would do 12 times 4, but then 12 gets broken down again because we just did it over here. The shortest way to do 48 would be to pick the largest square root, perfect square that goes into it, and that's 16. Now if you want a hint, think about this one. This one's going to have a 3 left over, so maybe 3 goes into 48. And if you took a calculator, did 48 divided by 3, you would have got 16. So use the other problem as a hint to what goes into the second part. So the square root of 4 is 2, so you get 2 square root of 3. The square root of 16 is 4, so I get 4 square root of 3. Let me bring down that minus 6, which is going to be times the 4, and bring down the 4 that goes in front of the 2. 2 times 4 makes 8 square root 3. 6 times 4 makes 24 square root 3. 8 minus 24 is negative 16 square root of 3. And the last one, 45. 9 times 5, 20. 4 times 5. And then 245, most people are like, well, what does that go into? Well, if the other two had 5s, I bet 245 could be divided by 5. And if you do that, you'll get 49 and 5. So square root 9, that's 3. So 3 square root 5. Square root 4, that's 2 square root 5. Square root 49, that's 7 square root 5. Here, there's no number in front, so just the minus sign. Here, there's no number in front, so just a plus sign with a 2. But in the very, very front, there's a 3 that's going to multiply. 3 times 3 makes 9 square root of 5, plus 2 square root of 5, minus 7 square root of 5. So 9 plus 2 is 11, minus 5 equals 4 square root of 5. And that's your final answer. All right, the last one. All right, here's some more multiplying things back together. Now, remember, when you're multiplying radicals, the outside parts are multiplied, and then the radicands are multiplied. So in A, 2 times 7 is 14. 6 times 3 is 18. And then 18 can be simplified. You should be thinking 9 and 2. The square root of 9 is 3. 2 can't be simplified. 3 times 14 is 42. So 42 square root 2. So if you'd like to try B, go ahead and pause. 9 and 11. That makes 99. 5 and 15. That makes 75. Hopefully you know that 75 can be broken down. You should think 25 and 3. The square root of 25 is 5. 99 times 5 is 495. So you literally get 495 square root 3. And then the last one here, in case you don't notice them, I'll make them a little bit bigger. We have parentheses. So distributive property works with radicals. So you need to multiply 3 square root 2 times 4 square root 3. So multiply the first numbers. 3 and 4 is 12. 2 and 3 is 6. And then multiply the second half. 3 times 6 is 18. Square root of 2 times the square root of 2 is the square root of 4. Now if you leave it like that, then you're not going to have it fully simplified. Now you should look at that part and try to think, well, what part can I simplify? And the only part that can be simplified is the square root of 4, and you make that into a 2. You then times 18 and 2, and you get 36. With 12 square root of 6, you can't simplify 6. It's only 2 times 3. Now, most mathematicians would want to see the answer written like this in the end. Instead, in these rare cases, they normally write the rational number first, which is 36, and then they will put the 12 square root of 6, which is the irrational part, last. Now, if you left it with the 12 first, I'm sure it would be counted correct. But if you were doing a multiple choice test or anything like that, traditionally people put the 36 first. Because the commutative property, you can switch it anytime you want. And that's it for 10.3.